A hollow cylinder having infinite length and carrying uniform current per unit length lambda along the circumference as shown. In earlier question, if you remember that, then there was current in a pipe along the length of the pipe. But this time, current is along the circumference. That means we can think of it like a solenoid. Yes, it will be something like solenoid. So it carries current lambda per unit length. Magnetic field inside the cylinder is. As we know that in case of solenoid, magnetic field, if solenoid is long enough, means infinitely long solenoid. So if the solenoid is having the infinite length, in that case, magnetic field inside the solenoid is given by mu naught Ni. Okay, here N is number of turns per unit length of this solenoid and I is of course the current. So now along this pipe, let us consider a segment of length, say dl. Then what would be the current in this segment? That would be the current. In fact, if we assume that if we divide this cylinder in several segments of dl length, then we can say that these are the current loops of dl width. Okay. So one turn I am assuming to be having a width dl. So what should be the current in that turn? The current in that particular turn must be lambda into dl, because current per unit length is given to be lambda. So here current has become lambda into dl. Since we are assuming one turn per dl length, then number of turns per unit length would be how much? 1 upon dl. Alright, now let us substitute these values over here. What we get? B is equal to mu naught into n. N is 1 by dl, number of turns per unit length, because in dl length there is one turn, so number of turns per unit length is 1 by dl. So in place of n and in place of current, it is lambda multiplied with dl. So dl and dl, we have got rid of dl. So it becomes mu naught into lambda. Okay. So in this case, option B has to be the correct choice.